Good morning, everybody. Welcome to the VTT Tech Talk. Hello, YouTube. Today we have a special guest, Dr. Tauno Vähä-Heikkilä, Vice President of Connectivity in VTT Finland. Tauno will talk about 5G Finland, the potentials and what it means. We are anxious to learn more about 5G. Not everybody is familiar with it. Tauno, the floor is yours.
Okay, thank you, Philip. Yeah, welcome everybody for this tech talk today, and the title that we have here is 5G overview and potential for Finland. I could have also stated the title to be maybe potential of 5G and possibilities then, but since 5G is still kind of big potential, nothing is really running yet on 5G. And what this 5G means, that it means the fifth generation of telecommunication, cellular communication systems, especially wireless ones. If we think about the past, so there has been 2G, 3G, 4G, and the 5G is coming at some point. And for example, in 2G, you can, if you remember backwards, one of the new things that came with 2G, okay, there was better quality voice. That was the main function that was intended to have there. But kind of big new thing was SMS text messages that were not before the 2G at all. And that was not even predicted before the 2G came. Then for 3G, there was plans to have this WAP type of things, to have a kind of text-based internet and so on, but basically in 3G the internet was one of the really big new things which was coming. And in 4G that was more like content sharing through internet and other channels like YouTube, social media and so on. And for the 5G, actually we don't know yet what will be all the new things. I will give some hints what can be expected in this presentation, but I think nobody can yet say for sure what is about to come with 5G. There are different kind of scenarios what 5G could be. So there are basically three big new features or kind of bigger scopes that 5G is promising something new. If we start from this picture from the lower right corner, so there is enhanced mobile broadband, and that means that the higher data rates, so I will come back to numbers later on, but basically much higher data rates that we have currently. Then there is mission critical type of functions, and that means more like topics where you need extremely low latencies. Something has to happen very fast, and also very highly reliable communication topics. And then as a third one is massive machine type communication, so lots of sensors and communication related to sensor related topics. And you can see several pictures within this bigger picture. So there is, like, as an example of mission critical application is like autonomous driving, where autonomous driving not necessarily with cars only, but with other vehicles, flying like UAVs and many other things. So where you need extremely high reliability and things have to happen fast, so that there's no too much time to wait that something is happening. Then also, if you think about the high data rate type of applications, which are very critical from high data rate and also from the delay point of view, you can think about virtual reality, that you need kind of a gigabit connection to transfer all the sensor data to the user, to possible users, and not to get headache for the users, you need to, everything should happen pretty fast, so that if something is happening somewhere and you want to have kind of virtual reality happening at the same time in another place. There cannot be too much delay, otherwise it doesn't feel real, and the users get quite a lot headache. And then basically the same picture, but from a little bit different point of view. So let's start from the upper part, where we now have this extreme mobile broadband, which means in practice high data rates. And 5G's promise is that there should be always minimum 100 megabytes per second speed, but in some cases it can be even 10 gigabytes data transfer speed. And the reasons behind that we need so much more data transfer capabilities is that, for example, every last year the need for data transfer by users has increased quite a lot. Finnish people, I think they are still number one usage of mobile data in the world, if you calculate per capita, and we have pretty good 4G network coverage, but in many cases you still don't want to wait that you are downloading something. Still it can take sometimes seconds or even more time, so everything should happen faster. And from the delay point of view, this latency is in practice delay, that how much if you decide to do something, how much there's delay. And for example, in LTE we are in tens of milliseconds, and that is for example too slow time that if you want to remotely operate, for example some helicopters or some flying UAVs or drones, if you want to operate them remotely in real time, LTE network cannot be used for that purpose currently. So that if you want to turn it quickly somewhere, then this delay that LTE network currently provides is too slow. So 5G tries to also help the users from that point of view. And then this massive machine type communication, there are industrial systems, but I think the biggest thing is that there will be much more sensors with lower power consumption. And for example, currently in LTE systems, that if you want to use SIM card in sensors, that is very expensive if you have tens of sensors and SIM cards, I mean LTE or kind of radio based solutions there. So currently there is like wireless LAN and Bluetooth and other competing radios, but within 5G the idea is that that would be much cheaper ways of realizing the communication. And also there's also for the SIM topic is that the operators will have much lower fees for the 5G sensor data. So these are kind of background higher level expectations for 5G. Timeline is so that there are some experiments going on already now, and I will come back to some Finnish test network topics, but in practice, when we have all of these, I don't know, will we have ever, but at least most of these are expected to have within users, let's say within after 5 years or so. So we still need to wait quite many years to have these in users, all of these possibilities. Then if we go a little bit to more practical things, that there are new frequency bands coming, and I think one of the big difference for 2G, 3G and 4G is that there are now expectations for microwave and millimeter wave frequency bands, and that means that the frequencies that will be used are maybe 10 times higher than they are nowadays. And that also, not all frequencies, but there will be some bands available for some specific use cases, and I will come back to those also later on. But there are also basically, typically within 5G, the bands are divided so that there are sub 6 GHz, or means below 6 GHz frequencies, and then above 6 gigahertz, which is typically microwave and millimeter wave frequencies going up to 80 gigahertz. And something, let's say, since we are here in Micronova, which is kind of place where we are developing technologies, and this is Tech Talk, so I also want to go a little bit deeper in some technologies and difficulties within this frequency bands that we see here. That, for example, we are using filters in radios, and there are some bandwidths that are, let's say, more than 10% of if the operating frequency is 4 gigahertz and we need to have 400 megahertz bandwidth, it's 10% from the bandwidth, from the center frequency, and then there are even wider bandwidths like 800 megahertz bandwidth around 4 gigahertz, which is 20%. And as an example, that we have been working with acoustic filters here in Micronova or resonators, and having this kind of 10 to 20% bandwidth, they are extremely difficult. I don't know if there are any technical solutions currently to cover this kind of bandwidth. So then let's go I show you some examples related to VTT's work, and I think this is not only VTT's work, there will be also examples how many Finnish companies are also involved with these developments. And I start with the test networks because that's quite a big activity in Finland currently. 5 publicly funded projects also linked to industrial developments. And we have a 5G test network Finland. There's a website that you can see more information, and this is kind of a framework for all Tekes funded 5G test network activities. And here are a few examples how these test networks are integrated. I don't go to the names of the projects and so much in details, but there are test networks basically in Oulu area, here in Espoo area, and Turku, some I think in Ylivieska and some other places in Tampere too, but let's say the main sites I think are Oulu and Espoo, where are the biggest activities going on. And for example, in this building, if you walk around here, you can see some base stations here, indoor base stations. I don't remember, maybe actually there you can see one white something like this size box on the the next floor from this floor on the corridor. So that is part of the 5G test network activities that we are doing in this building, and that is connected to the 5G test network. And all these national projects are also linked to the European level, and basically also projects in Asia and US, in some projects there too, but especially with Horizon 2020 projects. And there's quite a lot of technology development related to the 5G test network developments, but there are also business and regulation aspects, because regulation, I mean, we want to of course use as much frequencies as possible, but then there are some regulatory aspects coming, for example, in Finland from Viestintävirasto. I don't remember the English name now, but let's say from these kind of bodies. And there are many different technical topics that are developed within the test networks, and the idea is in the end that these test networks would be kind of service platforms that also, let's say, service development companies could use those, also vertical companies, like companies that are not really developing 5G technologies. Like I would say that like ABB type of vertical companies or energy companies can do trials in these test networks for their future systems. And here are examples of companies that are involved to the 5G test network projects. Might be that there are even more nowadays, but this is kind of situation that was probably end of last year. So you can see that there are not only companies developing hardware like Nokia, Huawei and Ericsson, but there are also many other types of companies. Actually, this is also quite funny in that sense that these Finnish 5G test network projects are probably the only projects in the world where all of these three competitors, Nokia, Huawei and Ericsson, are participating in the same projects. But these will be open for all kinds of trials and partly are already now, these test networks. Then I just saw shortly, there was a presentation on, I think on Monday this week about a new project. This is a practical project showing some practical developments just started recently. So smart 5G lamppost basically for smart cities, and there are many companies involved, and the idea is that this kind of lamppost network is developed within 5G communication capabilities, and there are some of the use cases for 5G that you can see in this picture, which are also general, that transportation, not only private cars but also how to get for example for public transportation as much data as possible, because people like to spend data when they are traveling and doing something else, not just sitting and waiting. Some other use cases is that I think one of the first use cases in 5G will be that how to have fixed wireless access or fixed wireless connection from base station to home. I think this project deals a little bit with that, but I think that is the first 5G basically product that will come in the US. Verizon and AT&T are driving that use case a lot, because if you want to replace the last mile cable connection, or if there is no cable at all for high data rate communication or connectivity, then there are lots of developments now in the US that how to get that wirelessly, and basically that will be microwave or millimeter wave link, similar to radio links that are used now between two base stations. It is expected that that will come quite soon in the US, so that you have base stations and you have wireless links to homes instead of having cables. And US is really driving that business case a lot. But within this project, we are also studying that how to get signals inside to the building. So if you think about houses with zero energy consumption, there are very thick walls, windows are, you have several glasses and some gases inside between the windows. So actually already with the 4G it's a big problem that how to get signal in. So we are developing now some new type of materials there, and then also for smart city services and how to build these kind of 5G networks in the future, because if the base station operation area is something like 50 to 150 meters from the base station, those will be really small area base stations, so you need a lot of base stations, and that's also kind of new problem for infrastructure design in different cities. And within this city we have there, within this project we have Espoo there and some city planning companies, and also new materials for lampposts and materials in general. And this project was just started, and I hope that next year, if there is a tech talk about 5G, we will have some concrete results on these projects presented either here or maybe some conferences here in Finland. Then this is a tech talk. I also want to show some technical challenges what I think that we have on hardware development. Micronova is the heart of hardware development, so I will show some not so much what we are doing currently, but what I see as as challenges there and also possibilities for Finnish hardware-oriented companies. If we think about radio hardware, I think that we need developments really from the materials point of view. In Finland we have several companies there working with new materials. Just to name like Premix in the previous slide with really advanced plastics, or Augmetic with advanced high resistivity silicon wafers. Then we have passive components, integrated circuits, antenna elements, like Opten is here developing simulation and optimization softwares for antennas. I think in 5G that is becoming even more and more difficult to design antennas for user devices like this or other form factor user devices. Then we have modular integration challenges and also subsystem developments. I think this is partly also from VTT's point of view that we are not really building the whole solutions, but from antennas and RF point of view, these are really critical topics. And just to show this in practice, that if we take one of these existing base stations, they are in the range of, let's say, 50 to 80 kilograms each. And it's about 50 to 80 liters. In this example, this is 75 kilograms, 75 liters. Then when we go to 5G, not necessarily even millimeter wave base station, outdoor base station, can be even microwave or sub 6 gigahertz base station. I think the size will be maybe, in the end, the size will be 1/10 of that. Maybe, let's say from 1 to 5 kilograms or 1 to 10 kilograms if the 4G base stations are from 50 to 100 kilograms range. And then when we go to indoor base stations, they are again one order of magnitude smaller. So we are talking about devices which are less than 1 kilogram, closer to this form factor devices. And these are base stations that you need in your homes to have high data rate connectivity. Just to show in practice, and what this means then, that we need new manufacturing methods or that kind of manufacturing methods that are not used currently in base station manufacturing nowadays. So we need more advanced manufacturing methods, similar to consumer products that are like this size. So because if you need to, all of you need to buy base stations to your homes, like now you have wireless LAN boxes there to provide wireless LAN to your homes. I think within a few years, might be 5 years or more, but you need to have 5G base stations probably in your homes. And just from, let's say, realization point of view, the base station units are big like this in the towers that you can see. And when we compare this to really integrated 3D solutions, then we are in the topics that are done here in the clean room, silicon-based solutions, which can be, let's say, less than 5 by 5 centimeter in size compared to the cable assembly there, which is like 50 by 50 centimeters. So this means that we also need to develop the manufacturing methods, integration methods, and really new technologies. And I think Finland has been strong in many of these topics a long time, and I think there are lots of possibilities also in these hardware-related topics. Not only developing new services, which is also important, but also new electronics products. And let's say, I think from the application point of view, 5G will have much more applications than 4G and former generations. And like our Minister of Communication and Transportation, Minister Berner, she just said, I was in some sort of happening 1 month ago, and she said that that she has been in this Mobile World Congress 2016 and 17, and her comment was that 2016 2016 everybody was talking that 5G will be the next generation, but and evolution of 4G, and but what she was realized that at this year everybody was talking that this will be a revolution compared to 4G. Let's see what happens within next 5-6 years. But I think that there are lots of possibilities for Finnish companies within 5G, not only developing the technologies but also applying these new features of 5G to their products, like energy companies, vertical companies, sensor companies, and transportation companies as an example. And of course, lots of interesting topics for scientific community to develop this or solve these exciting technical problems related to 5G. Thank you.
Thank you, Tauno, and thank you for the effort to popularize the topic. It was very interesting. Do we have questions? Several questions. Take first one here.
Thank you, Tauno. I want to ask about the frequency allocations. You show some frequency allocations. So when is the time when those will be fixed and allocated?
2019 will be the next World Radio Conference where for example, the microwave millimeter wave bands will be decided. But for example, I mentioned this use case for fixed wireless access to homes. Actually, in the US, those bands are already available now because they are former radio link bands and they can be used for this fixed wireless access already right now. But mainly for, let's say, wider coverage systems or mobile communications, not necessarily with mobile phones, but everything which is mobile, like cars or whatever. Those decisions will be done in 2019.
Next question. Oh, you're after.
What's your guess? Which percentage of these Internet of Things sensors actually require 5G? Because there are some companies developing like kilobit per second Internet of Things connections also.
Yeah, and actually that's a good question. That I say that there's this really high data rate aspect of 5G, but there's also this really low data rate, and that will be one of the, let's say, new features to support really low data rate sensor type of connectivity. So I think you can replace maybe all the sensors that are now connected to wireless LAN, but I think it doesn't make sense in all cases, so it's case by case, but 5G will support this kind of really low speed communication too. And there's already now in LTE, one of the standards, narrowband LTE, that if you check from the Google, you will find some definitions about narrowband LTE, and that is already more towards that kind of use cases. Like kilobit, kilobit or tens of kilobits speed requiring applications.
Okay, thanks for all very good review and information. About the latency or the delay when it's the goal is 1 millisecond, what is actually meant by that? And what I'm thinking here is that if I want to remotely control something from Finland to Japan, there's also all other delays involved. And so what is this 1 millisecond in practice?
Yeah, I think it is thought to be the delay from the user device to the cloud or the central data processing point, and then going to either back to the user or to the other user or sensor or whatever. So basically end-to-end delay. And I think that will be really difficult if there's long distance, because already going like with the speed of light from a place to another place, that needs some time already.
Which can be even more than 1 millisecond already.
Yes, for some, I think this is kind of a goal, and maybe for some applications it works, but not necessarily from here to Japan.
I guess you need 6G for that, but
Yes.
another question. Is the low latency going to be a feature that everybody can trust having for everything, or is it just an option where commercial offering will be reinforced?
I don't know yet exactly how that will be, but I think at least currently it is the goal that it would be there. But might be that there are different kind of how much you are ready to pay. I don't know let's say the business logic behind, because probably if you want higher performance, maybe then also price tag is a different compared to lower performance system. And actually new feature of 5G will be this kind of network slicing, that you can basically slice the network for different kind of use cases and requirements more efficiently compared to LTE.
Okay, in the test network, are there some partners I didn't see? I didn't really pay attention, but are there some partners who are developing new applications already and business models?
Yes, there are. I cannot really name who is doing and what, but you can see that many of the companies are not just companies developing.
Sure, certainly, yes. Well, it's making sense.
Just developing the hardware solutions.
Other questions? Okay, maybe a last one. What about the power? Does it require less power for the antennas, or is it the same as today?
Hopefully less, because this should be more energy efficient, and I think let's say compared to 4G, we will have, it's called massive MIMO, multiple input, multiple output antennas, and that means that in most advanced use cases there is a directive beam from the antenna, base station antenna, that follows the user, so that you are not radiating everywhere, you are just focusing to the user with the lower power also to the user.
Yes, exciting. Okay, last call for a question. Yes, we have one here.
This is not a question, but one comment that the standardization work is already ongoing, and the first release of 5G is expected to be released next year in late summer or autumn. But that is the early phase, and it doesn't include all the features and fine features which Tauno described here.
Yeah, but that was a good comment, that next year we will have kind of the first release of the 5G standard and the new radio that is developed.
Last question. Yes, here.
Just suddenly came to my mind. Should we consider some kind of different security compared with the 4G? Is it like on the hardware or software level?
Yeah, I think the security aspect is very important, and that's, to my understanding, that should be also better both in hardware and also software. I think you can also think it from hardware point of view, that if we have just that kind of use case, that you have a directive beam, that you are not radiating to everywhere, you are just focusing just as an example from kind of physical layer security point of view, that if you are focusing the beam to the user, if somebody wants to use that same information, then it should be, I mean, the person or whatever device that this should be in kind of between the user and the base station.
So in these terms, like 5G even better in the secure terms? Like, okay.
Yes, yeah, I would expect that 5G will be better.
Okay, thanks.
It's a chance that it's not worse. Yeah. Okay, last question. They are keeping coming. No question. You proposed to present results in a year, so even if you're ready before that, you're welcome. The invitation is open. Thank you, Tauno, for giving this tech talk. Thank you, everybody.
Thank you.